Of the day, logistics, where artificial intelligence takes center stage in optimizing efficiency, resource management, and sustainability throughout the steel value chain. Our next and final presentation of the day is AI-driven predictive planning to optimize steel deliveries, material reuse, and sustainability. For that purpose, we'll have with us, Mrs. Laia Soler from Celsa Group and Mr. Victor Muntés from Beware. Together, they will share how data-driven collaboration and intelligent planning are reshaping logistics to achieve greater operational efficiency and sustainability in the steel industry. It's a pleasure to have you with us. Thank you very much.
Okay, thank you very much. First of all, thanks to all the survivors in the room for getting to the last one. We promise to make it fast. And thanks also to Laia for being here, sharing the stage. This is a collaborative work between Celsa and Beware. And I will let Laia start with explaining the challenge, and then I'll talk a little bit about the solution.
Yeah, okay. So yeah, thanks for being here. We'll try to be light. First, an introduction. I'm representing today Celsa Steel Service Unit within Celsa Group. This is the unit that delivers steel directly to construction sites. Plus, we also build big infrastructures. So one of the main challenges of this unit is related to delivery times. We may have orders of within 5 days, then we need to produce as ordered, plus transport it to the production site. Plus, as we all know, construction sites are never as planned. We have a lot of changes in orders, and all this needs to be leveraged in the planning stage. So our planning teams from the CSS unit need to take into account all the data from the last manufacturing steps. This data is fragmented. Each machine has its own data. There are even decisions and reports that are manual, so it's not yet integrated. We also have operational risks that may lead us to delays related to logistics, raw material stocks, etc. Also operations, regulatory sustainability policies may change our operations. Plus, we have some more green products that have different labels and traceability requirements, and poor recovery material when the operations are not optimized. So all this leads to a lack of risk control that we were not having yet, and it's important for us. And we took it from a paper that if the whole industry, steel industry annually, could save $10 billion if they would optimize better their operations. And also for 4 billion tons of CO2 related to the steel that could be saved. So in order to solve this challenge, we partnered with our partners, Beware. They have already a system to improve risk control of operations that we can detect possible deliveries, delays on our deliveries and operations. So the main thing we asked is that we want a full integration into our existing systems. We don't want to build more. It needs to be modular and possibly with no more hardware. So we needed to work and use our own data and structure it. And our main goals is to optimize resources and delivery timing management for project management control. And now I basically give the floor to Victor to give us more details on the technical part of the solution. No?
Okay.
Well, sorry. I didn't know that was coming. The last numbers. Our teams are dedicated, 20 people is involved weekly in the planning of only this division in Celsa of operations. This is 2 to 3 hours of meetings a day, a week, 64 hours, and they need to take into account and leverage every time last order minutes, saturation on production lines, lack of raw material, breakdowns on production lines, and weather conditions in order to reach the delivery times now. Yes, now this is yours.
Okay, so let's talk a little bit more about the solution now. This pilot has been built on top of our platform. Our platform is a SaaS platform for continuous risk management. It's built out of several blocks for collecting data, automating processes, and controlling risks in real time. And it is also augmented with an agentic AI system which is able to interact in natural language in order to help you control risks in real time. The platform is always interconnected, and this is very important, with your digital ecosystem, with the digital ecosystem of the organization. So we use a non-intrusive approach. We never force the company to change the tools they are already using or to change the workflows and the processes they are using. And the platform is based on a set of technological characteristics, such as the fact that we are continuously monitoring risks. We are predicting what's going to happen, in particular with workflows, as I will show in a second. And we are automating processes, and all this integrated in the digital ecosystem. So with Celsa, what we were trying to solve, as Laia was explaining, is let's see if we can predict the risk that we have not to deliver in time when we have continuous deliveries every day. So we were basically using Be-Aware Control in order to, first of all, model what are the workflows that Celsa was using for these specific processes. Second, using Bowtie methodology, and I will explain it very briefly in a second. What does risk mean for you in a visual way and supported by the agentic AI system? Then being able, through digital twins of the workflows, and this is important because we are not talking about digital twins of physical infrastructures. We are creating digital twins of business processes. When things are going to happen, and then it automatically recalculates risks, and it provides mitigative and preventive actions, recommendations in natural language. So the first step is, OK, let's define the workflow. So we were defining, in this particular case, two different workflows, one for the approval of orders, and the second one for the production of all the pieces in each order. Basically, what we were doing here was through a proprietary AI engine where we are using several approaches. We are using gradient boosting, LSTMs, transformers, and we're using ensemble methods to basically use the ones that produce more accurate results depending on different characteristics of the data. The cadence of the data entry in the system, etc. We are able to learn not only what is the most probable path of this workflow, or not only what is the most probable remaining time, but we are predicting the distribution of the remaining times depending on all the different possible things that we have to do. And that's very important because we are talking about risk management. So we are not interested in the most probable path, which may have a probability of 10%. We're interested in all the possibilities and understanding, for instance, the risk of not meeting a deadline. So basically, our system is able to connect to all the evidences coming from other systems, SAP, your production systems, documentation management systems, connected to the process, so we understand how the process evolves, and we are able to understand or to predict when things will happen, thanks to these predictions, and therefore the probability of something wrong happening. For instance, being then late on a deadline, but also it could be any other thing that we define in the platform. Then we have to specify what risk means. And for that, we are using Bowtie methodology. The Bowtie methodology defines what's the unwanted incident, the top event that you want to avoid in the middle of the diagram. Then on the left side, you have the threats that may cause this. And on the right side, you have the consequences. And then you define, for the moment statically, what are the barriers, preventive and mitigative barriers. And you can then start calculating likelihoods, consequences, etc. For this, we have Nora, which is our AI agent. Basically, because we cannot guarantee that we will have a risk analyst in every plant or in every part of my operation. So our goal is to make sure that anyone, whether it is knowledgeable on risk management or not, is able to easily create one of these diagrams. So basically, with our agent, you can have a conversation about what worries you, what could be the problems that you may encounter in your operations, and the system will automatically create the bow tie diagram for you. And then you can connect all these boxes in the bow tie diagram with evidences coming from other systems. And all of a sudden, you have all the baseline to enable continuous risk management, which is our goal. Not only that, but also if this risk analysis was done in another plant, in another project, the system using RACs is able to find semantically similar bow ties in such a way that it can find them, find the differences, and make recommendations based on those differences. So all of a sudden, you are not using just LLMs to provide recommendations about threats, but you are leveraging all the knowledge on risk management in your organization. And this is one of the things that was essential in this project. And finally, the project is able, based on the conditions of the system, based on the data that you receive, is able to generate recommendations of preventive and mitigative actions in real time so that different people can act upon it, the responsibles of the process. Not only that, but it can also activate or enable, trigger, for instance, actions like sending notifications, emails, or activating processes if they can be activated digitally, and that's convenient for the organization. Last step. All this was to make sure that I enabled a risk-driven planning, and in this case, weekly planning. So basically, what the system is providing is a way to visually see the planning with all the deliveries per day with the risk information embedded, which is one of the things that is missing in most of the tools in the market. And basically, this allows me not only to understand the level of risk for the organization not to deliver in time, but also it's able to provide a what-if analysis platform, because I can drag and drop different activities. The system will automatically recalculate the risk of that delivery in the new day, and that helps you understand how realistic you are and to achieve the goal, which was basically trying to be successful in delivering in time as much as possible, given all these uncertainties in the process. So back to you.
Yeah, these are some of the KPIs of the project. This is an ongoing project, and we are now at the final validation step, so we will validate these KPIs. We expect up to almost 80 hours saved per plant in different operations, thanks to using the tool. Also some savings on material, because we could recover material from one delivery to use it for the other and do this matching. This leads to some 64 tons CO2 reduced annually. And the adding thing here is that, as the first speaker of the session said, the user is very important. So the tool is user-friendly. It's, as Victor showed, it's a chat with a language model. And this is important for our team. And that's also modular. So we would keep building up more steps of our operations into the same model. And yeah, that's it. And Victor's contact. Thank you.
Thank you.
Thank you very much. We have one question. How can predictive algorithms most effectively adapt to the volatility of steel demand and supply chain disruptions?
So it depends. In this particular case, what we were doing was monitoring evidence that tell us when the different activities in this process happen. I didn't have time to get into the details of those activities, but these are things such as a technician breaking down the order in different pieces. Sorry. In different pieces, or for instance, the customer reviewing this work and approving it, etc. So these are all aspects that are not depending on the demand, etc. But it is true that there are other aspects that may be depending on that. Basically, if you have a peak in the workload or you have a problem in your production lines, this may affect the deliveries. And we can easily see this here, because when you are planning on a daily basis, you can see very fast when you have accumulation of deliveries in one specific day. And therefore, that allows you to understand the level of workload that you have per day. And this is also taken into account in the different formulas that you use to compute the risk. In fact, in the bow tie diagram, you can specify a threat which is, I'm overloaded. And then you just need to connect the evidence coming from other systems that you are overloaded, for instance, the number of deliveries per day. And that helps you understand that the level of risk is rising. And therefore, that will affect, for instance, all the deliveries in a particular day.
Fantastic. And the last one. It has some typos. I think people is tired, but I'm going to try to translate it.
I thought it was a presentation. I said, check.
Yeah. Can the system itself, even to recommend to improvements, the operational workflows to reduce the redundant or now useful steps or optimize the workflow?
Ooh, can you repeat this one, please?
Yeah. Whose question is? Oh, Santiago Oliver.
Last session.
Wait a little bit, because you are going to have the microphone for you. Yeah. It's normal. I mean, it's the last one. We can't hear
Sorry,
properly.
when I was writing down the question, the self-improve of the telephone was changing my words. but can the system itself even improve the workflow in order to identify those steps that are creating the expecting delays, or because for whatever reason the operational workflow is not very well designed, so you are using some intermediate steps that are not creating any added value and maybe even somehow bridge over.
Yes, this is the next step. The good thing of creating a digital twin of a workflow is that you can make questions on top of that workflow that may or may not have not been observed in the past, because you have different models learning on how the workflow evolves. The first thing, and that's what we are working on, is on automatically detecting bottlenecks, detecting issues that may be affecting the performance of the organization. Maybe it's not on the workflow per se, but it's on the actor that is executing that particular step. So there are variables around the workflow which are also relevant for the performance. And then the next step that we are planning to do is then taking that into account to start generating suggestions on the workflow. This is something we are not doing yet, and that's not there with the pilot with Celsa. But it's a nice addition, and it's in the roadmap.
So you are going to identify the lazy people at the company.
I'm not going to do that. My customer is going to do that. But it's not only about finding lazy people, but it's also about understanding. Because sometimes someone is for instance, takes more time for someone to do a task, but it's also because it's the most experienced person that is handling the most complex tasks. No? But at least it gives you understanding as the owner of the tool to analyze what's going on and go deeper into that. No? And depending on the level of information that you have in the system may be more smarter at telling you exactly what's happening, or at least pointing you out on anomalies in the execution that you should analyze.
Thank you very much for the questions, of course, and thank you very much, Mr. Muntes and Mrs. Soler. It's been a pleasure to have you with us today. A big round of applause to them, please.